Hi everybody, I hope you're doing quite well. This is a video which I just thought to make in order to revise on certain areas of contravariant vector, which was the topic of my earlier video. I'm making this video just to revise and to make you aware because there has been quite a long calculations and you might have omitted or you might have thought that some important factors must have missed. So you can just call it as a summarization or a summary of the contravariant vector topic which we dealt in the earlier video. So I would just touch base on the important factors of contravariant vector so that you don't miss any topic, and the 40 minutes long video which carried a lot of graphs, lot of calculations are now summarized in just a few words and just few important topics. So let us start with this. This is the first part which I would like to show you where I have drawn the earlier diagram. Now you see here the blue arrow, this one E1, E2 are the two old basis vectors which we already know, and the E1 tilde and E2 tilde, these two are the new basis vectors. This V1 is the vector which we have drawn. From the earlier video, you have noticed that the values that we have got for the forward and the backward transformations are respectively this 2, 1, minus half, minus 1, 4. The backward transformation denoted by this word B is 1/4 minus 1, half, 1 half and 2. Now this is another point which I would like to draw your attention. You see that the old basis is E1 and E2. This one which is in the diagram. So this is a nice tidy one, E1 and E2. And the new basis vectors are the E1 tilde and the E2 tilde, which are colored in red. Right. And what we are doing over here is that we are trying to calculate the values of E1, that is the old one, E2, both the old one, and E1 and E2 based on this green vector V. So here you see for this one V, we have got one copy of E1 plus 1.5 copy of E2. For this vector, we need one copy of E1 tilde, the new vector, and two copies of E2 tilde. Just to bring your kind attention that this part, E1 and E2, right, 1 and 1.5 are the old one, and E1 tilde and E2 tilde are the new, old new one. So once we have got these values, we can write it in the form of matrix. So I have written EI, which denotes the new one which is derived. So 1, 1.5 and 1 and 2, which are the values which are written in matrix. This is the new one, old one, and this is the new one. So you see we have arrived at EI using the old basis vectors E1, E2. We have got the values 1 and 2, which we have got from the new basis vectors. And you see I have written below that using E1 and E2, which is the old basis vector, we have got these values 1 and 1.5, right? And using E1 and E1 tilde and E2 tilde, that is the new one, we have got 1 and 2 EI tilde, which is the new one. So this is the first part which I wanted to make clear. The graph where E1 and E2 denotes the old basis, E1 tilde and E2 tilde denotes the new basis. V is the vector with the values of forward transformation, and with the notation of old and new, we have got these values 1, 1.5 using E1, E2, and 1 and 2 using the new E1 tilde and E2 tilde. So that is why I have written that using this old we got these values, and with this we have got these values. Coming to the next part, which is another important, is that we are using backward transformation denoted by this word B using on old components. These are E1 and E2. So what are the values of B? We know this, and I have already shown it in this particular page. Yeah, this is from the previous video of this where we calculated the values of B. So what I'm going to do over here is that I am taking the backward transformation B, and with the old components, which is 1 and 1.5, which was already there, which is denoted by E1 and now by EI with an arrow, I am going for further calculations. So using the old basis vector B, I am using this one with the old one, and we are getting, I have not shown here the calculation, this leads to 1 and 2. This is in red. Why? Because this is coming from the new basis vector e1 and e2, and how it is coming, this is coming from the earlier v, which is 1 and 2, and we have seen that this is where it is. This one is coming from this particular part, right? e1 and 2, and that we have shown it here. So it becomes quite clear that doing this further calculations, we arrived at 1 and 2, which is the new basis, this one, and it is, I have shown it in green so that you can understand that this has come from the earlier 1 and 2. So what is the result? So you might think that what we have done. So just to review, you see that we have used the old basis vectors with its elements, and we have multiplied and done a calculation of addition with the old basis ei, which is 1, 1.5, and the final result is the new one, 1 and 2. So you see now why I have written that using B, that is a backward transformation, we find new components. This one are the new components, 1 and 2, which is the new basis. And now you see that we have summarized it in this way. Backward transformation 1, 1.5, which are the backward transformation elements, is equals to 1 and 2, which is EI, which is the new component, right? And we have just shown that, right? So this entire calculations basis motive was to use the old components on the basis on the backward transformation elements and getting back to a value 1 and 2, which gives us the new value 1 and 2. This is from the new basis. That is why it is written in red. So what is the summary? The summary gives us this. Using B, we find the new components 1, 1.5, we get 1 and 2, which is the new one, and 1 and 2, by using 1 and 2 we get the earlier one, which is 1.5, which is the E1, EI, which is the old basis vectors. So that is why I have written C, backward transformation. This particular part gives us old to new. This is old one and this is the new one, blue to red. And forward transformation using the red gives us 1, 1.5, which is the E1, which is the old. And that is why I have put up several question marks. And here is what actually contravariant vectors comes into the play. So in general, when we tell of forward transformation, we need, when we are going forward, so it would give us something new. So from new we are going forward to old, and backward means from old we are going back to new, but it is just the reverse. We are using backward transformation, but we are getting a new value. We are going forward, that means we want a new value, we are getting an old value. So this is why I have given this question mark. So this is actually contra, that means it is varying in different directions. We have also seen this one, so I just thought to give you a better idea. This is an example. So you see this is the basis vectors E1 and E2 in blue, and we have drawn V, which is the new vector, and it is given in the values 1 and 1, 1 and 1, right? This is almost 1. So I have written the components of vector V as 1 and 1 because the length is almost 1. Now what I have done is that we have increased the size of the basis vectors E1 tilde and E2 tilde has grown up to this size, and vector V has shrunk to half, although it looks like it has shrunk, but it has been invariant, which we have dealt in the earlier video. The size of the vector V remains same, but because the basis of the vectors have increased, it looks that it has gone down, it has shrunk. So I have written basis gets bigger, that means E1 and E2 gets to E1 tilde to E2 tilde, and the components shrink. That means it becomes half and half. So here the elements are 1, 1. We have scaled this basis vectors to twice the size, and it has gone down to half and half. Here is another classic example where again we have got the old basis vectors E1 and E2, and there is a vector V which is almost 45 degrees in this angle. We got an angle theta, and we tell that theta 1 equals to theta 2 because more or less it seems the same. When we rotated this vector, so this vector is lying in this direction, and you know it is rotating like this, it's rotating in this way. So it gets a new coordinate E1 tilde and E2 tilde. The vector V remains the same, but angle theta 1 is now greater than theta 2, right? And this V vector seems to be inclining, it is going towards the angle, towards the new basis vectors e2 tilde, which was this e2, which has rotated and got this kind of a shape. So here theta 1 and theta 2 has been the same. Here theta 1 is greater than theta 2. So that is why I have shown you, written here, that basis rotates clockwise in this way, but the components rotate counterclockwise in this way. So these are the two classic examples, and that is how, again, this shows how contravariant vectors, contra in general English means opposite, and contravariant vectors means that it behaves exactly in the opposite direction. So these are the two examples where the basis vector has grown up from e1, e2, it has gone up to e1 tilde, e2 tilde. The vector v remains the same, but the scaling part reduces to half. Here these e1 and e2 tilde is in this shape, but once it is rotated, it gives back to this, and angle 2, theta 1 seems to be bigger than angle 2, and note that angle v, the vector v is seem to be inclining towards the new basis vector e2 tilde. So that is why it is opposite. So whatever the way basis is growing up, the vector is getting shrinked. Basis is rotating clockwise, it is rotating counterclockwise. Whatever the way the basis behaves, the components of the vector behaves exactly in the opposite way, and that is why we call them a contravariant vector. So these two examples clear up the concept. Coming to the next part, this one we have already seen that forward transformation can be used as a summation of I indices 1 to n forward f gi of ei, which gives a value of ej tilde, which is the new one. So using forward transformation, we are getting the new one. This is for the basis vector, mind it. Just don't get confused that this is for the old vector. This is for the basis vector. For ej, which is the new old basis vector, we are using backward transformation, and we are getting the old basis vector. So this is quite okay in case of a basis vector. As you see, using forward f, we get a new basis vector ej tilde. Using b backward, we are getting ej. So this is quite clear, but it is not in terms of in terms of component of vectors. So now you see what I have done is that I have used the same equation, but now I think it will be much more clearer, because earlier I was doing the equation, so I was writing. So v, which is the old basis, I can write it as a summation of j equals to 1 to n vj ej, which is the 1. Now this ej, as you can see, is also over here, right? So I can substitute this ej over here, right? And I get this one, j equals to 1 vj, further calculation sigma, this one, and then we get bji vj. Now what is this bji vj? If I get an ei tilde, this is the new one which I denoted as vi tilde. So this vi tilde is the new one which we got it. It is a simple operation where I have substituted the value of ej, right? It is this ej, mind it. This ej got substituted over here, right? And we got this value, which is more or less the same as the indices vi. And here I have written again vi equals to j equals to 1 to n bji vj. So this middle term becomes equal to this vi tilde, which is the new term. Rearranging, I have shown that this one equals to this one. So this one is the old one, you see, this old one, because we are using backward transformation, we are getting the new one. So again, it is contra, right? We are using the backward to get the new one. But mind it, for the basis vectors, things are pretty simple, because if you are using bj, you are getting you are using the new one, the old one, you are getting the old values, that is through backward transformation. Through using b, you are getting ej. But what is happening by using b, you are getting vi tilde. So this is for the backward transformation. Let us see what happens with the forward transformation. Here it is quite simple. For forward transformation, it is ej tilde, and we are using forward, so it is f, and I have written this is forward transformation. Now again, starting with the old basis vector, j equals to 1 to n vj ej. Again, I am substituting this ej with this ej, because this is the, you can see it is red one, so I have to substitute this one. So further calculations, vj equals to 1n, and this, and putting up the summation, we get this one. What is this one? This one, vi, is the old one, right? So because we have substituted the middle term, we have substituted this one with the this one, this ej part. So we substitute here, and what we get is vi. So this is an old one. So again I have rewritten that sigma j1 equals to vj equals to vi, which is the new one. So we can definitely write that we are using this one, which is the new term, and we are getting back to the old term. Why it is new? Because we are getting vj tilde, which is a new component. So again, from new we are going back to old. So here you have got two things, which is quite clear. From here, from new you are going back to old. So using the new forward transformation, we are supposed to get to the new one, but you are going back to the old one. Here we are using the backward transformation. We are supposed to get to the old one, but we are getting the new one. So here we are getting the new one, here we are getting the old one, and that is why it behaves opposite in direction, and that is why they are called contravariant. This one, contravariant, opposite. So can we summarize this in few words? Here is the summary. Okay, I will put in a fresh paper. Okay, so this is the summary, right? So see, this for the basis vectors, again it is quite simple. Ej, which is the new basis vectors, gives a summation of I equals to 1 to n fji ei, and here we are using the forward transformation. Again, this is the old one, ej, which is using old basis vectors, and hence we are getting an old one. But here is what is the contra part. So vi is the new one, we are getting it from b, which is the backward transformation. Remember, this vi tilde is the new one, which we derived earlier. And vi, just the vi, which is the old one, we are getting because we are using the forward transformation. So this is the new one and this is the old one. So vector components are contravariant. Just remember this thing if you're getting confused, that in general backward means you're moving in this direction. So starting from one point, you're going back to that point, you're moving in the back direction. That means you're going back to the origin. That means you're going back to your home, and your home is the old one where you started. But see, you're starting with something new. Similarly, when you're going forward, that is from home you're going to your college, that means you're going to a new one. You should get a new one, but here you're getting an old one. This is a funny example, but I think things were quite clear. Lastly, what I would like to show you is that how the indices behave. And here I won't be using a pre-designed template, but I would just like to show you how the indices look like. Okay, so for the indices, I would just like to show you how we write it. So we can write this one, V equals to a summation of I equals to 1 to n, right? Vi ei with an arrow, and this is also equal to sigma. There is a summation of I equals to 1 to n Vi, and this is the new one, and I have to use my red pen, which is ei tilde, right? So this is the conventional summation that we know, but because there is a part which is a contravariant, we need to change this, and we need to write this as V equals to sigma of I equals to 1 ranging up to n. But this Vi, what we are going to do is that this I is going to shift up. So I can write in this way, this will be V and this would be I, right? It is shifting up. I will just in a minute explain how it looks. Then I will say EI, right? And it again equals to sigma of I equals to 1 to n, and this I again is going to shift on the top. So we will have a tilde, but this will have I on the top, and EI tilde will be the same. So I can write it as EI tilde. right? So this is indication, or you can call it, this is what happens in case of contravariant vectors, that the indices do change. So this one which has gone up and this one which has gone up, let me circle it for you. This one and this one, these two mentions that these two are contravariant vectors, where the basis vectors will stay at the bottom, this one and this one. So you can call these two as basis. These two are the basis vectors, and these two, I don't have a space, but I can just show an arrow. These are, contravariant vectors, contra. Right, this one and this one. So what happens in, this is the general notion, this V will shift to the up, this I will shift to the up. Upstairs means contra, and the lower stairs means that they are basis vectors. This is a general convention. Just note one thing, when we are using this, you might think that what is going on the top might be an exponent, but don't worry, exponents do not come in between tensors, analysis, etc. So you can safely assume indexes which are going on the top will be the contravariant vectors, and indices which are coming at the bottom are the basis vectors. Just to show you at the last, this part which we will come later, I've just drawn a graph x, y, and this is a graph which is coming with m, and x1 and x2, these two are covariant components, which is the topic of our next video, how we can find out and know and understand about covariant components. This x1 and x2, which is written in red, are the contravariant components. So x1 and x2 in green, you see these are perpendicular. This x1 and this x2, these are perpendicular to m. You can see this one and this one, right? And x1 and x2, these two are parallel components. So we can use a general notion m equals to this, but using Einstein summation notation, which is we are going to learn soon, we can omit the sigma part and we write this one as m equals to m on the top, and you see j on the bottom. Why I try to show you this part is because I have shown you how the contravariant indices go on the top and the basis basis remains at the bottom, and here also it is the same. So we are using mj on the top and ej at the bottom, and using Einstein summation convention, we are omitting the sigma part and we are just writing mj. That means it is the contra, ej it is the basis vectors which will remain at the bottom. Thank you very much. I think things are now quite clear and you can have understood about the contravariant vectors. You might be thinking why I made two videos, but it was important. Until and unless we clear up the concepts of contravariant vectors, how these things happen, we won't be able to understand the covariant vectors. So this is how it happens. I hope you like the video. Simple yet to the point. I am including these writings of mine, if you want to consult at any point of the note, in my timeline, as well as in my page of Stephen Hawking. You can just have a note, have a look onto it so that you can understand. And if you have any comments, please put it up in my channel. Subscribe, like it, and stay happy and have a nice evening and good day. Thank you very much for watching it. Bye.